Today on the bench we have a General Electric. This is a model 3-5825A. There were two versions of this radio. I'm pretty sure I've done a video on that a while ago on the two different versions. This is the A version. There was also a B version. The A version is a single board chassis, and physically the radio is longer. And then the B version has the dual stacked circuit boards, which are exactly the same as in the GE Super Bass. And that one also added a coarse fine clarifier, where this just has a single control. And then I think this control here is also a dual control. It has, what did that add? I think the mic gain. I think it is. But and these switches then turn to slide switches, I think. They still do the same exact functions, but if I remember right, I think I'd have to go pull mine and see, but I think they turned into slide switches. But otherwise, physically, from the outside, they look, from the front, they look pretty much the same. Internally, 100% completely different radios. Like I say, this is a single board, the other one's a dual board. Is one better than the other one? Yeah, that's kind of subjective. They're both Cybernet chassis, both really good radios. Yeah, they're both. The B version may be a little bit better, but you'd honestly probably, if you weren't using test instruments to do sensitivity tests and whatnot on air, I seriously doubt you'd really notice much difference between the A and the B versions. Now this one was sent in, let's see, 3-pin standard power cord, and it's why I haven't taken this apart yet. I want to take it apart definitely before I plug it in. I'm not even sure if this thing works. Haven't powered it up, haven't done anything to it yet. I'd have to go back and check emails, but I'm pretty sure this might be the radio the customer told me someone hooked up a power cord backwards. Now this radio from the factory would have had a 2-pin power cord, not a 3-pin power cord. The 3-pin power cords, I don't want to say it's impossible to push those in backwards. It'd be really hard, but trust me, people can do anything. But the 2-pin power cords, it's very simple to install those backwards, unfortunately. They have, actually, let me see if, 2-pin power cord. Grab one here and show you what the heck I'm talking about. So they have this style plug, and it just has a little divot out of it right there. The problem is this style is rubber, and it flexes a little bit. And if you're determined, you can push this in backwards, because the spacing is exactly the same. Where the 3-pin power cords, 2 of the terminals are closer together and one's a little bit farther apart, so it's really, really hard to push those in wrong. This one, yeah, the pins, just flip it upside down, give it an extra shove, and yeah, it'll go in backwards, and you can let the magic smoke out. I think that was what happened to this radio. The thing is, it already has a 3-pin power cord, so I'm not sure who did that. It might have been the customer, I'm not sure. Doesn't say on the note. So basically, once anything fixed that needs to be repaired, once a electrolytic capacitor replacement, just by the age of this radio, it needs that done. The transceiver alignment, as you can see, obviously, there is a little black box attached to the top of this permanently. That is a red code digiscan. So this is a frequency modification. So instead of doing toggle switches and whatnot, what you do is basically disconnect the channel selector in the radio. You unsolder the ribbon cable from that, and the ribbon cable that comes out of the little red code digiscan module goes in its place. And that's all this does. It's just basically a programmer for the PLL chip. It just provides the proper, basically, ones or zeros to the divider, the input pins, to program the PLL chip to tell it what channel to go to. And by using that, you get every possible channel. Now, he said he does not want this radio broadbanded. Let me see how he words it here. Transmit and receive, no broadband. Peak performance on 26965 to 27405. So, I'm assuming he just wants to use it as a CB. Of course, it already has this box on there, but yeah. So, now, thinking this one had the one that had the magic smoke let out, we definitely, whatever we do not want to turn this radio on without inspecting the inside first to see what might have been blown up. I also noticed there's no speaker I don't know if you can see that, but I see wires. Why would you take the speaker out? It doesn't look like there's a echo board or anything in there. I don't see anything that looks like it's in the way, so I'm really not sure. We shall see momentarily. I don't think there was anything on the note there either about a speaker, so I'll have to contact him, and it doesn't look like there's any reason for the speaker to be missing. I'll see if he wants me to stick one in there. Definitely makes it a little bit easier to listen to your radio if it has a speaker in it, that's for sure. And some of these screws look a little bit mismatched, so I'm sure this thing has been apart and put back together several times. We'll never ever understand how in the world people work on radios and lose all the screws. And it happens all the time. I see that. Okay. Of course, we have to be careful with the Digiscan module here. So, well, first appearance. Can't say I'm seeing. Just give it a quick sniff test. No, it just smells like an old radio. We like the smell of old radios. We don't like the smell of burned up radios, though. I don't see anything burned up, so maybe this wasn't the one. I really think this is it. And yeah, there's just no speaker. There's the wires, but did it just go bad, I guess? I don't know. Yeah, it looks like it just needs a speaker reinstalled. Now, I already do see something that definitely isn't supposed to be in here. Actually, I see several things that aren't supposed to be in here. Not in the back of the radio, but in the front, in the synthesizer circuit here. And these have absolutely nothing to do with that Redcode Digiscan, because actually the Redcode Digiscan's very simple to install. Like I say, it just programs the PLL chip. Basically, it needs power, ground, and the wires to go, actually flip it back over here, show you. See, you got a couple extra wires, but mainly it just goes down and it just takes the place of the, did they, Butcher installed this, God. They could have just desoldered the wires that come down off of this channel selector switch. No, they just whacked all the traces off. So if anybody ever wants to restore this back to original, they've got to repair all of those circuit traces. That's butcher work. Just unsolder the wires, people. Oh no, never mind. I'd see why they did that. Yeah, this doesn't have a ribbon cable. This is, Cybernet. Yeah, this has the channel selector solders directly to the circuit board. So, yeah, that wouldn't have worked so well. So, yeah, they either had to do that or remove, and I actually did that for a customer one time. I asked him, I said, I can cut the circuit traces, or I can take the channel selector out, desolder it, dismantle it, take the switch sections out, put this part back in that has the shaft and the ratchet mechanism, the clicky part. I don't know if you can see that down in, darn it, where's my little flashlight? See the teeth right there. You can reinstall that, and then it fills the hole, and it still goes click, 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 but there's just no channel selector wafer element in there anymore. And that prevents you, again, from having to cut the circuit traces. And then if you ever want to restore the radio back to original, you just pull it back out. You can put those sections, slide them back in, resolder it in. But yeah, did that wire just break off, or is that... yeah, it looks like that might... Anything, got to be careful with these things. All those little wires will start to snap off. But I do see a bunch of stuff that's not supposed to be here. That is definitely not supposed to be in this radio. There's a tunable inductor. That capacitor, which goes down to... Of course, I can't see anything because the camera's in my way. Good Lord, goes down to another coil. Where the hell does that coil go to? I'm going to assume all of that's... Oh my God, look at this mic jack. Well, this is weird. He said install a 4-pin mic jack. I just noticed that. That's another thing he wanted done, was to install a 4-pin mic jack. It already has a 4-pin mic jack. 1, 2, 3, 4. Yeah. Why? Unless he just wants it done so it doesn't look so screwed up. Yeah, I'm kind of getting lost here. He wants a 3-pin power cord. It already has one. He wants a 4-pin mic jack. It already has one. Unless that's still wired factory style. Because GE uses the Cybernet style of mic wiring. And it is a 4-pin mic plug. But I'm just assuming it was... Well, let's see. Cobra audio's on 2, GE audio's on 1. Where is the key? It looks like audio is on 2, shield to 1. That would be Cobra style, so I don't know. I'll have to check all that. I'm really beginning to wonder what the heck did somebody do to this thing. Otherwise, it doesn't look too bad. Rest of it looks, to give her a good once-over, but for the most part, looks original. Looks like mainly somebody's been working on the synthesizer, VCO, PLL circuit, and that's about it. And removed the speaker for some odd reason. I don't know why. But let's get her flipped over here. The camera up out of the way a little bit. We don't have any shorts here. I don't think that black wire was actually attached to anything. There's grounds. Those two, both of those go to ground. Both of those look like they go down to the volume control for power, so yeah, black was probably just not used in this application. So, reach over here and fire up a power supply. Get this turned this direction. Just want to inspect this power cord. Stay. Since this already has a 3-pin cord, I can get rid of this 2-pin one. Did they install that right? Yep, the single pin goes to hot. They didn't do a very good job of mounting it. They glued it in, so maybe that's what he wants done. He just wants it installed properly. And there should be another ceramic cap on the negative lead like there is on the positive here for filtering. That's missing, so that will have to get installed. And let's hook up a speaker, since we have a big gaping hole where the speaker is supposed to be. Okay. Flip it around there. Make sure she's turned off. And let's see if there's any life. Nothing. Dead. Let's see. First thing I want to do, just verify. Never know, you may have a blown fuse in your own power cord. I've seen people chasing their tail before where they tried to track down why a radio wouldn't turn on. You know, I can't lie. I've probably done that myself a couple times over the years. You're trying to figure out why it's not working. It's come to find out the fuse is blown in your own power cord. Or did my fuse just blow, possibly? That's possible as well, if there's a short somewhere. then again, I did just... Yeah, I've had my bench torn apart. I don't know if maybe did I knock the wire? I will just turn that and make sure that's off. Oh, I just saw a big spark. When I went to plug my cord in up there at the other jack, I saw the terminal sparks. I'm assuming this fuse probably just... Yep, it just vaporized. So we have a dead short definitely in this somewhere. So I have to check here and see what happened where... Now the radio was turned off when I did that. But like I say, somebody's been soldering wires on here to the power switch. So you have a continuous hot into the power switch all the time. So yeah, it's hard to tell what somebody might have done. So I need to do some troubleshooting here. See if maybe somebody did hook up a power cord backwards, or if they just have something shorted out somewhere else in this radio. And I shall report back. So I need to get this faceplate taped up on this anyhow. So let me get to doing a little bit of taping, and we'll do a little bit of troubleshooting here, and I'll be back and let you know what I found, why we have apparently a dead short on the power supply. So this will be a good one to, I'll go through some of the troubleshooting procedures for troubleshooting just that. You turn your radio on and it blows the fuse instantly, or in the case of this radio, even with the radio turned off, the instant power was applied to it, it blows the fuse. Now I'll tell you right now, one thing that you can do, if it has accessories like this Redco Digiscan, don't assume this thing works. Always assume the worst, that it doesn't work. So an easy thing to do is, the first thing you can do, disconnect the power cord. These two wires go up to the switch, disconnect them. If you disconnect these two wires and turn it on and your short is gone, it's your accessory. So it could be anything from like this, a frequency modification module, or it could be an echo board, Roger beads, whatever accessory might have been added to your radio. Make sure that's not causing a problem. It looks like that's really all that's been added, other than a few parts. Like I say, I got to figure out what the heck they did down here. If they were just, that's the varactor diode. So yeah, that's probably for to broadband it, which he doesn't want it broadbanded. But yeah, let me get to troubleshooting here. But like I say, I got to tape it up. Probably the first thing I will do is disconnect the hot wire to this Redco Digiscan. The next thing I'll do, if you work on this type of stuff, ideally you should have a current limited power supply. It makes life a lot easier. Well, it's not so much easier. In the long run, it's cheaper because you don't have to go replacing fuses all the time. So I just blew the fuse. I know we've got a high current draw problem. You're going to decide to roll off the bench, aren't you? If you have something like that Astron down there, that's a 50 amp power supply. Okay, that goes up to a distribution panel, and that's where I'll plug the power cords into. The problem is that thing's not current limited. Now, it's got a fold back on it, or actually a crowbar circuit in these. If it's a dead short to that thing, if you were to short across the terminals, it will crowbar the output. But still, it's not current limited. Ideally, what I will do now is, from now on when I power this radio up, I'll turn that power supply off and I'll turn that one on. That one has those two knobs right there are current limit, so I can set it to like a half amp. In receive, this radio definitely shouldn't be drawing even a half amp's worth of power. So I'll hook it up through that power supply, put a new 4 amp fuse back in the power cord, but the power supply, once it gets to that half amp or whatever I set the current limit at, the voltage, you'll just see it plummet. You'll go down to 0 volts and you'll have, or like point something volts, but you'll see a half amp of current. Like I said, that protects fuses, protects electronics from burning up. So power supply, laboratories type power supplies that can be adjusted for a current limit are very nice for doing troubleshooting like this. So let me get at it, and I'll come back and let you know what I found and troubleshooting procedures to get you to that point. Okay, so I do believe I've found the problem. So, troubleshooting was fairly straightforward. Have not hooked it back up to a power supply, didn't do any of the current limit yet. I'll get to that when I go to try it. But I had extremely low resistance directly at the power jack. So with the radio turned off, I was still reading less than 1 ohm of resistance between the positive and negative leads. First thing I did was to disconnect this wire from the Redcode Digiscan to remove any external accessories. Checked it again, still had basically a dead short. I have several times seen light bulbs short out. You wouldn't think it happens, but it does. Don't ask me how. I'm not a light bulb, engineer, but I have seen light bulbs literally short out and cause dead shorts before. So while I was disconnecting the wires for the Redcode Digiscan, I just pulled the wire off for the meter light while I was at it. But that verified it wasn't that. The next thing to do is basically eliminate the rest of the radio. We want to try and isolate the immediate power supply circuitry right where the power comes into the radio. And we can do that by disconnecting the on-off switch. Because pretty much everything in your radio, almost everything you see on this circuit board, is after the on-off switch. Now there are a few components, a few coils, reverse protection diode, and a few things like that, and a few ceramic capacitors between before the power switch. So an easy way to isolate that is remove the feed line that goes from the power supply circuitry to the switch. So that's what I did here. I just desoldered the wire tie post and pulled that post out. Checked, still less than 1 ohm of resistance, like 0.1 something ohms. So that's a good thing, because we've just eliminated everything else in this radio. The only thing left are a few components right directly coming in off the power jack. And the first thing that I'm going to think there, it's going to be a solid state device. Because ceramic capacitors usually don't fail. Coils, well, it doesn't matter if they short. It won't be a coil anymore. If the coil was to completely short out, because basically a coil is a dead short to DC power. So you really don't have to worry about those. But the reverse protection diode, on the other hand, it's a solid state device. Yeah, they can do all kinds of weird things. So I just removed it from circuit, tested again, infinite resistance now on there between the positive and negative. So it's definitely the reverse protection diode. So I removed it, and it's actually right here attached. And if we look at the ohm meter there, we can see we have just a hair more, 0.071 ohms. Now, even in forward direction, a diode should never have resistance that low. Or ideally, it'd be great if it did, but they're usually not. They're going to have higher resistance than that. But if we reverse the leads here, you can see we still have 0.02 or 0.0734 ohms. So yeah, it's just a dead short. So the reverse protection diode crapped out on it. So now what's kind of strange is looking at this little guy, camera back down. What's kind of strange about that is it didn't blow up. Usually when these things go bad, they'll vaporize. The only thing that'll be left on the board are 2 pieces of wire. I've seen that, and I'm sure if you work on radios, you've probably seen that before too. This one looks like the day it was made. It looks fresh and brand new, but yeah, it's a dead short. So I'll stick a new one in. I'll get. Now I will leave this disconnected for the moment, yeah. So I'll get that stuck in, get her powered up. If the radio turns on, then I'll reconnect the power line to the Redcode Digiscan, and hopefully that's all it was. There wasn't anything else. So I shall return in a moment. Well, I got the new diode in, and there's good news and bad news. The good news, you can see, it turns on now. The bad news is, the only thing it does is turn on. There's no receive, there's no transmit, and there is also no audio. So it has multiple problems. I did a little bit of diagnostics on the no receive and transmit. Now, on anything with a Cybernet chassis in it, usually the absolute first thing I go to is check to see if I have the correct frequencies at the test points in the synthesizer circuit, and if anything looks out of whack there, first thing to do is check the VCO, because all of the Cybernets use a VCO block. This one actually has, you just reach over and grab a bad one. This is one in the to be rebuilt pile. You could say I have bad written on it. This is the exact style that's in this radio. This is the VCO can, the potted and epoxy kind. Common for them to go bad in these radios on their own. You don't need to be having power line problems. They're known for just going bad. But that does not appear to be the only problem with this radio. So it does look like the VCO block in this one is bad. I checked the VCO voltage on the VCO test point. I can run the core from the top to the bottom of its range. VCO voltage doesn't budge. The other thing is, it looks like probably the audio amplifier is bad. Not sure that maybe why the speaker was removed. Somebody thought maybe the speaker was bad. Don't know. But I'm taking a stab at it. I haven't even tested anything there other than using my finger. And I'll show that in a second. But I'm assuming that's probably why the speaker was removed. I'll just take a guess that somebody assumed because there's no sound, the speaker must be bad. Which, don't get me wrong, the speakers do commonly go bad. But I'm going to say probably the audio amp itself, the IC right here on this heatsink, is bad. Easy way to tell there is, now don't be doing this with anything vacuum tube. Now honestly, even radios that plug into an AC power line, the radio chassis itself, they're just the same boards that are used in mobile radios, so they're low voltage. The highest voltage you're going to see in here is 13.8 volts, but just anything that plugs into a wall, you definitely want to use caution and know where you're putting your fingers at. But in a radio like this, there's no voltage over 13.8 volts. And an easy way to tell if the audio amp is good or bad is just wipe your finger across the terminals. If you touch almost any part of the circuit, the input circuit on an audio amplifier, you'll hear a rubbing sound, basically, coming out of your speaker. So I have an external speaker plugged in, have verified there's nothing wrong with that speaker. Rub my finger across the board all over the place. I just rub all four fingers under there. There's absolutely nothing coming out of the speaker. So, yeah, it looks like, I don't know, maybe somebody did hook up a power cord backwards in this thing, burned up the reverse protection diode, and it just went short. The VCO, that may or may not have been caused by this problem. Honestly, I'm just thinking of the circuit that's what's actually in that can. I don't think even if you hook the power up backwards, you'd really damage anything inside of the VCO. I mean, at the most, the electrolytic capacitor, but the voltage is going through this. I somehow doubt if it was a reverse voltage hookup problem, I don't think that would have caused the VCO to go bad. The audio amp, yeah, that's very possible. If the power supply was hooked up backwards, because that does feed pretty much. You can see how close it is to the power input of the radio. That's because it does feed off basically the main supply voltage. So yeah, it's very possible that got nuked in the. And there's no telling what else might be wrong with this radio. That's the only thing when you run into radios like this that have possibly had the power line hooked up backwards. You can fry stuff from one end of the radio to the other. Yet I've seen other radios that had horrible circuit trace damage. Traces from the front of the radio to the back, just poof, they just vaporized. There's nothing but a black carbon trail left on the board where it just blew the trace off of the board. You repair that circuit trace and the radio works just absolutely perfectly. Maybe replace a exploded reverse protection diode. But yeah, I've seen radios where it just nuked traces off of the board, but you repair the trace, replace the reverse protection diode, and the radio works perfectly fine. Didn't do anything else to it. And you'll get radio like this. Absolutely no circuit trace damage, and has the potential for having lots of problems. Lots of bad ICs. I don't know if the PLL chip's any good anymore. There's a lot of things in here I don't know if they're any good anymore. Like I say, it looks like I haven't done any measurements, but I'm going to assume if I take some test measurements on the audio amp IC, I'm going to find everything's out of whack there. So, yeah, I really need to contact the customer now before going any farther, because Lord only knows what I might find wrong. If it was in, possibly even if it was in voltage is, if it's a semiconductor and it was hooked up backwards, there's a potential for everything solid state in this radio, not everything, but a large majority of parts could possibly be cooked. Usually it's going to be stuff like the audio amp IC, maybe the PLL, the integrated circuits don't be hooked up backwards. Most of the transistors will usually be okay because they're deep enough into a circuit that by the time the voltage gets there, it's at a reduced level, or it's basically protected by other circuits in front of it. But yes, I'll contact the customer and see how far he wants to go, because this is one of those things, I'm not going to say it can turn into a bottomless pit when it comes to how much it's going to cost to fix. But it does get to a point where how much money do you want to put in it? Now this is, I don't want to say it's a rare radio, but these are hard to find. So it's not like you're just going to click onto eBay and you're going to find 50 of these things for sale in good condition. They're hard to find to start with, and they're even harder to find in good condition like this one, good physical condition, other than the 2 holes in the top where somebody mounted the mounting bracket for this thing, which is, I hate it when people do that. But that's a whole other story. But yeah, so let me get a hold of the customer, and we'll see if he wants me to. The first thing I'll do is I'm not going to worry about the audio circuit first, because having audio is not going to do me any good if I can't get the radio to receive or transmit. So the first thing I'll do is replace the VCO block, and it's very simple to do. Now, in a radio like this, I'm pretty sure the customer does not obviously want this thing put back to original, factory original type condition. It's got a frequency modification done to it. So, and holes drilled in the top cover. So, using aftermarket parts for the VCOs, probably not going to be a problem here, and it's a lot faster. And what I mean by that is just install a modern replacement VCO board in this, or VCO module into the radio. Just take the factory one out and pop this one in, and alleviates all the trouble. If you watch my videos it's a very time-consuming process. They are repairable. It's just you have to be very careful, and it takes a lot of time burrowing down in through all that epoxy to get to the parts you need to change in there. But yeah, it's just cheaper. In the long run, it's cheaper and faster to install one of these modern replacement VCO blocks in there. So I shall return. We'll see if he wants this. See how far down the rabbit hole he wants to go. Okay, so we're back. I thought actually before I contact the customer, because the VCO block's not really that hard to change in this, and if it's not it, I can let him know. I've tried the VCO block, and it's going to need a lot more diagnostics. A lot of times, like I say, I just, from experience, what I saw, measurements I made, bad VCO block. So I just really quick popped out the old one. So there was the old one. Stuck in the new modern replacement, and we turn the radio on. Now remember, don't pay any attention to this display, because this doesn't actually do anything for the radio anymore. All the traces are cut to that, so you actually use this. So what do I have my signal generator on? Actually, I got it on channel 19. So there's channel 19, and if you look at the signal meter, you'll see the needle's actually moved. If I change channels, it goes away. So it is receiving, and if I go into transmit, I got 4.26 watts on AM, so it's working. Now, actually sideband, let's see here. Audio. Yeah, nothing on the audio circuit, and that actually doesn't even use the audio amplifier, but we appear to be having definite audio problems. But Major concern for me always is a synthesizer circuit. Audio circuits, easy to diagnose usually, stuff like that. VCO circuits can have, and actually this is going to need some work because the frequency is off. I know the clarifier is on lock. Let me just center it here. Key the mic again. And because it would help if I put it back into AM for a carrier. Yeah, and the transmit frequency is 27.18099. So yeah, it's off by, say, about 4,000 hertz. And I honestly, I gotta figure out what the hell they did. Like I say, they've got all these parts bodged in here. Actually, did they? Actually, need to look at the service manual here. Did they take out a trimmer cap? I believe they did. Yes, they took out. Yeah, I really have no idea what the hell they did now. They removed a trimmer capacitor. That's what all this, well, at least some of this stuff is bodged. What in God's name did they do? They've got this blue wire. Okay, actually, you can, well, no, you can't. Try reposition the camera, maybe you can see it. Okay, yeah, that's better. So if you look down in here, you can see right there is a trimmer capacitor. Well, there's supposed to be another one right here. There's actually an inductor, wire-wound inductor, down here. It goes to this blue wire, to this capacitor that goes over to the can. And the other end's open, so yeah, what in God's name did they do here? Did they... I mean, if the trimmer was bad, that's your adjustment, that's your frequency adjustment. There's nothing adjustable here anymore. And actually, I gotta figure out what the hell this blue wire is. Yeah, they've taken the adjustment out of it. So how are you supposed to calibrate the radio? Yeah. Oh, the things you find. And see, now that actually goes to what looks like, it may not be it's a diode. And there's supposed to be a ceramic capacitor across the... yeah. But it works. The radio works, it transmits, it does receive. Like I say, I've got a signal. Put it back on channel. Go up one more channel. Bink! There you can see, and I'm feeding it with 50 microvolts into 50 ohms, so that would be an S9. So, it's showing what, S7. Like I say, alignment hasn't been done, so yeah, I'm sure that's way off, but yeah, we're receiving fine. And you can see as I change, yeah, and actually that's because we've got to remember we're off 4,000 hertz. So as I turn the clarifier up, you can see the receiver sensitivity increases because we're getting closer to the actual frequency. And I turn it down the whole way. Yeah, this thing has like batshit crazy amount of slide, I guess. Actually, let's just check really quick. So it's in AM. Camera back up there. Key the microphone. So there's with the clarifier centered. That's full counterclockwise. So that's, it should be, I'm on channel 19, so that should be 27.185, and we're at 177. And then full clockwise, 1 to 8. So actually it's only 10 kilohertz, 5 kilohertz each way. That's actually quite a lot. That's a ridiculous, honestly, it's a ridiculous amount of clarifier range. The problem with that is, with this style clarifier, it's just a single, it's not a coarse and a fine control. It's so hard to clarify people in when you have a clarifier that has massive amounts of range like that, so that's why I never do that. So, yeah, I'll have to, but I can contact the customer now, let them know. The radio now transmits, it receives, you just have no audio. There's no transmit audio, no receive audio. I need to basically remove all of this crap, ask him if he does want to the clarifier unlocked. If he doesn't, I can just put it back to factory the way it should be. And if he does want it unlocked, I can do it properly. With, like I said, I don't know what the heck were they doing. And just, I gotta figure out, like I said, I gotta trace this blue wire and find out where in the heck this even goes. What they have tied into the clarifier, or to that, what used to be a trimmer capacitor for the frequency adjustment. Oh boy, man, some people and soldering irons. It's scary. So next time you see this, I will have contacted a customer and gotten some guidance as to how far, like I say, down the rabbit hole he wants to go. Doesn't look very bad. The VCO problem's been fixed. That's just basically some undoing some butchery. And like I say, I'm assuming probably an audio amp IC, which isn't going to be that much either. And what other problems there might be, but if we're showing receive, showing transmit power, fairly close on frequency. May not be perfect, like I say, haven't done an alignment and all this goofy stuff, but yeah, it's looking like it's definitely worth repairing. It's not like this is a basket case, so it just needs a couple parts and should be good to go. So I'll be back again. Okay, so I got the audio amp replaced. While I had it out, I went ahead and did the electrolytic. I'm going to replace all the electrolytic capacitors, but I've replaced the ones in that immediate area there. And she's working, well, you can hear we're receiving a signal, and we have transmit modulation now. So AM sideband are working, but I immediately noticed, because I didn't want to go recapping the whole array. I wanted to really quick try and get that problem solved, and then get rid of all this hackery going on up here. And wow, I mean, whew, speechless. What they did was, I'm not even sure how to put this into words. Well, I'll just show you. So they had, I'd shown you there was a trimmer capacitor just gone. It just was not in there anymore. They had removed that ceramic trimmer capacitor. So this capacitor, this trimmer capacitor, this capacitor, and the varactor diode had all been pulled out. And this blue wire, okay, that had been cut off of a post over here. This blue wire is supposed to be in here. That's a factory wire, and that goes to the clarifier. That goes to the wiper of the clarifier. The clarifier then has, of course, potentiometers have 3 terminals. The blue wire was attached to the center. One end is left open in these from the factory, and then the other end goes to ground. They had taken, now when you do a normal unlock, you volt the clarifier because you're removing its receive and its separate receive and transmit voltage sources, and you'd be applying voltage. So they did that. They took the open end and attached that to an 8-volt source back here at the regulator. But the rest of it, yeah, they just, wow, I don't think in my life ever seen anybody do a clarifier modification quite like this. The first thing I noticed when I turned this radio back on after replacing the audio amp over there was, all you had to do was touch this radio and you could hear yourself. I could hear my finger. I'd rub my finger on the side of the case here, especially if I did my fingernail. I'm not talking grounding. This entire radio chassis was picking up the vibration. You would tap the chassis and it would come out of the speaker. Anywhere. I mean, you get anywhere in this radio, you tap anything, and you'd hear it in the speaker, and it's like, what in my God is going on here? And then I was like, I wonder if that's some of this hocus pocus going on up here that somebody had in here. Well, yeah, that's exactly what was causing it, was all that, whatever they thought they were doing. So what did they do? And I didn't write it down because I don't do much as far as reverse engineering shit that I'm going to be removing, but I was kind of curious to look at this one, so I kind of at least tried to half pay attention to these parts that I was removing. So actually that is the original varactor diode. Well, I'm assuming it's probably the original. It is an ITT310, which is what would be in this radio from the factory. But they had removed this ceramic capacitor, this trimmer capacitor, this ceramic capacitor. They had applied voltage to the clarifier here, which when you're unlocking a clarifier, that's what you'd normally do. But then they cut the blue wire off, basically right here where it attaches to 0.179. They took that blue wire then and attached it to, where they have that attached? They had that attached to this little coil and this big ceramic capacitor. They had this stuck down in the hole where this trimmer capacitor here was removed. So they had that in there just like that. And then this end went to the can of one of the transformers. So this end was grounded. They had this ceramic capacitor on the bottom of the board, which was probably it was probably this one that they had removed. But they had this installed right here. So they had removed the varactor diode out of the radio, installed this ceramic capacitor on the bottom side of the board where this diode used to be, and then looks like they probably used the original varactor diode that they took out of the radio, attached it to this coil, which had this end here attached to the shield inside, so again, DC ground on that side, and then this end went right here, right at the crystal, because they stuck that in the hole where this crystal, or this ceramic capacitor was. Yeah, I have never ever seen. The problem with that is you now have all of these inductors and with wires, much less, going to them. The slightest movement of anything here is going to change its relative position to other things, metal inside the radio and other electromagnetic fields in this circuit. And that's why you just barely touch the radio and you'd hear a sound come out of the speaker because the frequency was so horribly unstable. And that's what it was doing, was basically the frequency was jittering back and forth. Because like I say, right there's your crystal, 10.0525. So they had, all these long wires and parts just bodged in and, just not well thought out. So I've contacted the customer. He does want this radio fixed, so that's why I've stuck the audio amp in there. Once I got it back up and got it running, it did transmit and receive. I wrote him an email, said I've just temporarily stuck a VCO block in it. You see there's a new one in there. It did transmit and receive. He said, go ahead and fix it. Asked him about a clarifier. Did he want it locked or unlocked? He said he wants this radio factory, of course, with the exception of the VFO, which, it's got holes in the top cover. So I'm assuming that's why he just wants to leave that on here. He wants it tuned for channel 1 to 40. He said he could really care less about the rest of them. But so he wants the clarifier factory configuration locked. So that's what's been done. So I stuck in a new trimmer capacitor here. These two capacitors are new. And I stuck in a new varactor diode down here. Now it looks different than what originally was in here, because this, like I say, was an ITT 310 diode. What I stuck in down here, or losing it in the camera view here, right there, looks like a transistor, but it's not. That's actually a Motorola varactor diode. But did that, put the blue wire back down to where it's supposed to be on the board. It works fine. Receives fine. You can see I'm putting 1 microvolt into it right now on channel 19, modulated 30%. Key the microphone. You can see we have power, and if I, as I'm talking, move the microphone closer here, you can see it's audio modulation. So switch over to sideband, audio. So, and it sounds funny because that's still injecting in a modulated signal with a carrier. I just flipped the switch on the radio over to sideband. But so it's just basically removing a bunch of, shall we call it, hodgepodgery. I've never ever seen anybody do a clarifier unlock modification like that by tapping into the crystal's basically frequency adjustment or disabling part of the frequency adjustment circuit, because they removed the trimmer capacitor, and then tying the clarifier in. So actually, I guess that's what you could say they did. Basically what they did is they completely disabled the entire clarifier circuit. Honestly, this control was no longer a clarifier, really. It wasn't doing what a clarifier would normally do, the way it's meant to do it in this radio. they used this circuit here to more or less replace that trimmer capacitor. That's in a nutshell what they did. I guess actually, and that part. But yeah, that's basically what they did. They replaced that ceramic trimmer capacitor with this circuit. Very, very unstable circuit. So, yeah. And actually, that's not. It's not even a rate. It's not even an NPO cap. And really, 1 kilovolt? How much voltage do they think is in the crystal circuit in this thing? And it's not an NP. Anytime you replace the capacitors in oscillator circuits like this, preferably they should be temperature compensated type capacitors, so like NPO type capacitors. Yeah, you don't go using, this is like a high voltage bypass filter cap or coupling cap. Yeah, you don't use that in sensitive oscillator circuits. But so it works. Everything seems to be working just fine. Yeah, receiver, actually, I mean, that's 1 microvolt it's receiving. It does sound a little like I say, I haven't replaced any of the rest of the caps in this thing. So let me get to recapping the rest of this thing, and I think it should turn out just fine. Looks like, so honestly, the only things that were wrong with it, overall, the main faults was bad VCO block, bad audio amp IC, a shorted reverse protection diode, and this hodgepodgery. So, let me get a recap, and we'll see how she turns out. Okay, so she's all back together and done now. Good working radio, just what you would expect from a GE, or actually Cybernet. GE just made the cabinet and whatnot, but basically what you would expect from a Cybernet. Superb receivers. They just, like I said, I just personally prefer the Cybernet chassis. I don't think there was really much else I changed other than, I guess, the power jack. Because, yeah, somebody had already changed out the jack on this thing, and they glued in this thing, and they were missing one of the caps here. So, and it was, the way they had it glued in there was crooked, and yeah, it's just easier to just stick a brand new one in there, scrape off all the blasted glue, and put 2 new proper caps on the power line there to the chassis ground. But yeah, other than that, replace the cabinet screws. Oh, I did put a speaker in it, so it'll actually have sound when you turn it on now. Almost wonder if somebody took the speaker out thinking maybe that was bad when it was the audio amp. Who knows? It's hard to tell. Doesn't really matter. It's got a speaker now. So right now it's currently on channel 19. Now remember, this display, when you have one of these things installed on a radio, your channel selector is absolutely useless. So I'm going to assume this radio has been on probably somewhere like 20, 21, 19 maybe its entire life. The reason I say that is if you actually turn this, you can see the display digits start to, yeah, they start to dissipate like there. It's completely blank. There's nothing wrong with the display. It's just the channel selector hasn't been turned in so many decades. It's just so the contacts are so oxidized, they can't even make contact. You know, if you sit there and go like this for a half an hour, they'll probably start to come back. It's just it hasn't been turned in so long. Yeah, there you go. It's starting to come back already just doing that. But like I say, it's useless. It really doesn't do anything. In all honesty, for now that I've turned it, it probably won't do it. Probably the best place to leave this would be like right there, where there are, there's some digits starting to show up. Yeah, if you could find a place where there were no digits and they just would stay out, that would actually be perfect for this radio, because the display up there is actually what you use for your channels. So in case you're not familiar with these, they have 2 spring-loaded toggle switches. They go up and down. This one does 1 channel or 10 kilohertz at a time steps. And then this one over here is a high speed. So this does every possible combination for the PLL. So it goes from 28005 to 25,995. Now this radio, customer wanted it tuned basically like you would at the factory, for a factory alignment. He did not want it, excuse me, did not want it broadbanded. So actually a lot of the alignment, your transmit power and whatnot, when you adjust these. Another reason I kind of like the Cybernets, they actually, instead of center tuning, they'll have two transformers in a couple circuits, and you'll tune one transformer for maximum on channel 1 and another transformer for maximum on channel 40. But in any case, this thing has good power from the CB band up to the top of its range, and it has fairly decent power a little bit below, but once you get down to here, yeah, there's yeah, it won't even key my communications. Actually, I think the PLL may be out of lock down that far. Oh, actually, it'd help if I was an AM too, and I'd have a carrier. Nope, it actually keys it at a whole whopping 0.07 watts. You can see 25,995. It's just what's on the down here. Yeah, whole 0.0. I say 0.07 watts, and we scroll up a ways. 26,295. It's up to a watt. 26,785. 2.93. And actually, the power is set at right around 3 watts on this. But yeah, the customer wanted the power turned down on this. But in any case, get back up here to channel 18. And we'll flip the sideband. Let's see, I already had the volume turned up on the radio. I just need to turn it up on my communications test set here, so you can actually hear it. And you can see on channel 19, I'm putting in 0.05 microvolts, and we're getting actually 19, 18 to 19, 20, yeah, it's bouncing around there, dB synad, so really good reception. If I change to AM, modulation. And I'd call that one right around. It's staying steady in 12s, not dropping below. So yeah, 0.15 microvolts. So, or minus 123.5 dBm. So, for AM, that's really, really good. So there you go. There's just another old dead radio brought back to life. I mean, anything I really questioned and scratched my head about was there. Actually, the more I got to thinking about it, this channel mod that they did, I had showed how they had that hooked up in there before. If you think about that, basically what they did was, if you had taken this control, you see this thing's meant to be mounted to a chassis, and then stick a knob on it. So this is meant to be tuned with a knob. If you were to mount this external to the, I think that's maybe, yeah, okay, yeah, it's actually got the screwdriver slot in the end there. But if you were to put a knob on that, and the way they had it set up in this radio, and mount it externally to the radio, that would have been a VFO. That's basically the way where they had this hooked up directly to the crystal. It was basically more or less a VFO. Oh, and speaking of which, because they had done that to the radio, they had the frequencies, so, as the camera pops out of the mountain here, hold on a second. They had the frequencies so screwed up on this poor thing. If you can see, they have, I'll probably never get the reflection just right, but you can see there's some stuff scratched into the face, the aluminum right here. What they have is, I'm even having a hard time seeing it. What is it? Minus, hell, camera's in the way. I can't get my head in here close enough. What do they have? Minus 5. So if the clarifier was here, that's minus 5, kilohertz on AM. That was 0 on lower sideband. That was 0 on AM. That was plus 5 on lower sideband. And, oh yeah, the whole way back around here, down here, that was -5 on lower sideband. So you, every time you changed bands, the clarifier was in a different... It wasn't the same for the different modes. So lower sideband, yeah, it just... And that's because of the way they did that. They just completely screwed that circuit up. That was just, yeah, wow. I've never seen anybody do it quite like that before. Got to give them thumbs up for attempting. I mean, they obviously knew partially what they were doing. I mean, they were smart enough to figure out that they needed to volt the clarifier. It's just... And they knew that changing capacitance and inductance at the crystal would affect its frequency, but you'd think that right there would have told them, yes, but then that's going to throw off my frequency into different modes, and I'll never get the clarifier adjusted to where center is zeroed in all three modes. They just, like I say, they knew enough to do this. Somebody just... some nitwit's not going to be able to figure this out, basically, is what I'm saying. They were smart enough to know how to do some of it, but by the same token, they screwed it up so bad that, yeah, I don't even know. That's why I usually don't even pay attention to shit like that. I see stuff like that, just remove it, and that's my best advice. If you ever see hokey stuff like that in a radio, parts that just make no sense, don't waste your time trying to figure it out. I mainly did it to try and explain to you guys what they had done. But when you see stuff like this in a radio, do yourself a favor. Just get out your wire cutters, your soldering iron, desoldering iron, whatever. Remove it and put the radio back the way the service manual, the schematic in the service manual shows it's supposed to be. Because this had this thing, like I say, you can just tap the radio, rub your finger across it, just the slightest vibrations. Because of the way they had all this stuff in there, just was... Wow. I don't know. So there you go. There's a restored GE 3-5825A.